Hello everyone and welcome to the presentation Interdisciplinary CS1 course for non-majors, the case of graduate psychology students. The research was held by me, Kobi Mike, and Orit Khazan, who is my PhD supervisor at the Technion Israel Institute of Technology. The presentation today has 4 parts. I will first describe the background to our research, then we will present our research method, results, and the conclusion. The background for our research is data science education, and there are a lot of definitions for data science, and this is one that I especially like by Skinner from 2017. And Skinner says that data science is a new science focused on generating value from data. So we'll start with real-world data, and data science is focused on the methods to extract value out of this data, and value can be out of several categories. It can be social value, like in the case of education. It can be scientific value, or it can be economic value in the case of the industry. Data science is an interdisciplinary field integrating knowledge and skills from computer science, mathematics, statistics, and different application domains, for example, social sciences, education, health, and so on. What is the motivation to teach psychology researcher or psychology graduate students data science? There are 2 motivations. The first is to expose the graduate psychology students to new research methods, and data science can be considered as a research method, and to expose them to state-of-the-art artificial intelligence and machine learning models that are inspired by the human brain and human thinking. And this is especially interesting for students in the cognitive psychology division. The second motivation is to address the market demand from the industry for data scientists that have a confirmed background in social science, like psychology graduate students have. This Venn diagram visualizes very well the research problem. While the graduate psychology students have a firm background in psychology and in statistics, they do not have the required background in computer science. Today, CS1 courses, or Introduction to Computer Science, are divided into 2. There are CS1 courses for CS majors, and those courses will use a very high level of mathematics, and they do not fit pedagogically for non-computer science majors. Other courses are CS1 courses for non-majors, but those courses usually do not achieve the required programming level that is required for data science applications. As we had to design a new CS1 course, we decided to do the research using the action-based research method. And we designed the course with 3 learning goals. The first is to develop students' computational thinking. The second is to enable students to collect data for social psychology research using web scraping, and we did this with Python. And the third is to enable students to collect data for cognitive psychology research using computerized experiments, and this was done using JavaScript. On the right part of the slide, you can see the new course that we have designed, and it includes computational thinking, web design and HTML, web design and JavaScript, Python programming, and then web scraping with Python and computerized experiments with JavaScript. This course was a total of 52 hours course given in 1 semester. This course is a part of data science specialization for the graduate psychology students. And the second course in this specialization is data science for psychological science, and it included the data science workflow, table manipulation with Python using Pandas, visualization with Python using Matplotlib and Seaborn, statistical inference with Python using SciPy, the principles of machine learning, supervised machine learning, unsupervised machine learning, and text analysis. Again, a course of 52 hours in 1 semester. We asked two research questions. First, does the interdisciplinary CS1 for psychological science course supports the non-major students' learning needs? If yes, what are the main characteristics that supported the learning, and if not, why? And the second question, does the interdisciplinary CS1 for psychological science course meets the programming level required for non-major data science students? To answer this question, we used the following research tool. 3 questionnaires, 1 introductory questionnaire at the beginning of the semester, 1 mid-semester questionnaire, and the final questionnaire after the semester was over. We also used participant observations by me who taught the course, and we used the student submissions. I will now present the results, and to present the results I will use the self-determination theory. The self-determination theory is a broad framework for understanding human motivation, and it includes 3 components. Autonomy, which is the sense of initiative and ownership of one's action. Competence, which is the sense of mastery. And relatedness, which is the sense of belonging and connection. And the first result is regarding autonomy, and we can see here in the graph a comparison of students' evaluation on a Likert scale between 1 to 7 of the different learning activities that were given in the course. And we can see that the asynchronous lectures and the individual tasks were rated higher than synchronous recitations or group tasks. And this can be explained by that the asynchronous lectures and the individual tasks supported the students' need for autonomy. The second result is regarding competence, and this is the sense of mastery. So first of all, this is for a quote from a student's reflection, and he or she wrote, "It is great to realize that I can build experiments on my own, and I am sure that I will use this ability." And most of the students in their reflections stated that they feel mastery and competence in programming. On the graph on the right, we can see students' answers to the question whether the course pace is too fast, too slow, or just right for them. And we ask this question after every lecture, and we can see that most of the students agree that the course pace was just right for them. This result was quite surprising for us because in the course we teach 2 programming languages, both Python and JavaScript, and we didn't know if graduate psychology students who had no background in computer science will be able to learn within 1 semester 2 programming languages, but it worked okay. And the third result is regarding relatedness. And we can see that relatedness was developed by focusing all the course exercises and the final project on data collection for psychological research. And we can see that one of the students said, "I think this course is significant for social science students. The course teaches an important research domain which is rapidly growing these years." So focusing the course on the psychological domain gave the students the sense of relevance and the relatedness of the programming for their own research. We can now answer the research question. And for the first research question, does the interdisciplinary CS1 for psychology science course support the non-major students' learning needs? We can say that the answer is yes, and the course enhanced students' internal motivation by enhancing autonomy, competence, and sense of relatedness. Regarding the second research question, does the interdisciplinary CS1 for psychological science course meets the programming level required for the non-major data science students? We can say that the answer is yes, and we know that since the projects that they developed are part of their real research, and the successful implementation of the data science projects proved that they acquired the required level of programming to work on data science projects for research in psychology. To conclude, I would like to present a new method to develop an interdisciplinary course, and we know that this is difficult to develop an interdisciplinary course, and there is a hierarchy of interdisciplinarity of courses, and in this case we worked on the two higher level of the hierarchy, and we introduced an interdisciplinary course using real-life data from the psychology domain, and the students themselves collected this real-life data, and they even used this real-life data for their own research. Using this method, we can introduce an interdisciplinary course that is integrated into the psychology domain, without the need that I, as the instructor, will have a deep understanding in psychology. So this might be a new and very interesting way to introduce an interdisciplinary computer science courses. That's it, and thank you very much for listening. Goodbye.